Hello friends, in this tutorial I will discuss about different types of engineering curve formed by the intersection of a cutting plane with a right circular cone in different ways like parabola, ellipse, hyperbola, etc. First of all, what is a right circular cone? It is a geometrical shape generated from revolution of a right angled triangle considering perpendicular as an axis. Suppose this is a right angled triangle. This angle is 90 degree. This is base B. This is perpendicular P and this is hypotenuse H. If I rotate this right angled triangle considering this perpendicular as an axis, then a three-dimensional shape like this will generate. This is called right circular cone. Two-dimensional, it will look like this. This is axis, this is base, this is called slant edge or generator of cone. This is apex and this is height of cone. Now I will discuss various engineering curves that can be obtained from a cone by cutting the cone at various conditions. First one is triangle. This is a right circular cone and this is a cutting plane. To get triangle, we have to cut cone from apex to center of the base vertically. You can see it. In this triangle, these two sides are equal and equal to slant length of cone. In two-dimensional, this is a right circular cone. This is axis of cone and this will be our section plane. Second one is circle. If cutting plane or section plane is parallel to base or perpendicular to axis of cone, then a circle will obtain. You can see it. This is a circular shape. In two dimension, this is a right circular cone. This is central axis. And this is our section plane or cutting plane. Third one is ellipse. If cutting plane is inclined to axis and cut all the generators of a cone, then a elliptical shape will generate. You can see it. In two dimension, this is a right circular cone. This is central axis and this is our cutting plane or section plane. Fourth one is parabola. If cutting plane is inclined to axis and parallel to one of the generator of cone, then a parabolic shape will obtain. You can see it. This is a parabolic shape. In 2 dimensions, this is a right circular cone. This is central axis of cone. And this is our section plane parallel to one of the generators. Fifth one is hyperbola. If cutting plane is parallel to axis of cone, then a hyperbolic shape will generate. This is a hyperbolic shape. In 2 dimensions, this is a right circular cone. This is central axis of cone. And this is our section plane parallel to axis. These conic sections are always smooth. They never contain any inflection point. These curves are important for many engineering applications like aerodynamic, civil engineering, mechanical engineering, etc. Now I will discuss the concept of conic. Conic is defined as the locus of a point moving in a plane such that the ratio of its distance from a fixed point and a fixed straight line is always constant. Suppose a point P moving in a plane such that the ratio of its distance from a fixed point F and a fixed straight line is always constant. Then this fixed point F is called focus and this straight line is called directrix and the fixed ratio is called eccentricity. So, eccentricity E is equal to PF upon PM or distance of point from focus upon distance of point from directrix. The value of eccentricity E is less than 1 for ellipse, equal to 1 for parabola, greater than 1 for hyperbola, and equal to 0 for circle. The line passing through the focus F and perpendicular to the directrix is called axis of conic section. The point at which the conic section cut the axis is called vertex V. Since vertex is also a point on conic section, so we can also write as E is equal to PF upon PM or VF upon VC. This point is C. This was the introduction of different engineering curve obtained from section of a right circular cone. In next tutorial, I will discuss about different methods for construction of an ellipse.